we're looking at two more examples for this cos to the mx, sine to the nx. But we want to look at the two examples that qualify for where we say both are even. Okay, in other words, we'll be just saying there's nothing odd there on the powers. All right, so the first example that qualifies, or for something that qualifies, is if you get an integral that says, please find the integral of, say, 5 sine to the 4 or theta with respect to theta. Okay, and maybe they want the answer correct to, they want the answer to 4 significant, and it's from 0 to pi over 2. Now, how are you going to do this? How would you evaluate this integral? Well, first thing first, you have already identified that it's something related to, it's your even power. Both are even, so it fits the even power. Now, if you remember, when we had a sine squared x, automatically we knew that we are going to use the double angle formula for cos, and that's the same thing we're using here. We're still going to use the double angle formula for cos, especially the one that is related to sine, because we know that cos 2x is equal to 1 minus 2 sine squared x. Right. Now, we can have our sine squared x, the subject here. Remember, it's now cos 2 theta is equal to 1 minus 2 sine squared theta. Let's see what we can get. Well, I take the 2 sine squared theta to the other side, the negative 2 sine squared theta, it becomes positive 2. So it becomes 2 sine squared theta, and it's equal to 1 minus. I take the cos 2 theta to the other side, it becomes negative. So 1 minus cos 2 theta. And I divide both sides by 2, and I can find my sine squared theta being equal to a half of 1 minus cos 2 theta, because dividing by 2 is the same as multiplying by half. So now, what I know is that sine to the power of 4 of theta is equal to sine theta to the power of 4, which is equal to sine theta squared, all raised to the power of 2 again. And you know that sine theta squared is sine squared theta, and it's raised to the power of 2. You get sine to the 4th of theta. So that's what I have. So I'm going to split that, and I'm going to say, okay, that means I have the integral from 0 to pi over 2 of, remember, if we're multiplying by a constant, we can take it out. So we now have sine squared theta raised to the power of 2, and it's with respect to theta. Now, we know what sine squared theta is, isn't it? And we know that it's half 1 minus cos 2 theta. So I can have 5 integral from 0 to pi over 2 of half, okay, of half, I can put square brackets here, half multiplying 1 minus cos 2 theta, and everything, because this is sine squared theta, this everything is raised to the power of 2. So you have to be really careful there, okay? From 0 to pi over 2, everything is raised to the power of 2. Now, if I raise half to the power of 2, I multiply the top, I square the top, it still remains as 1, over I square the bottom, 2 squared is now 4. And this is multiplying 1 minus cos 2 theta all squared. Okay? So I kind of have it like that. Well, if I then go ahead, then I would have again here, if I expand, I can take that quarter outside. So I now have 5 times 1 over 4, and it becomes 5 over 4, okay? Because 5 is a whole number, it multiplies the numerator of the fraction. So it's 0 to pi over 2 of, now remember we learned how to square. We said when we're squaring, we square the first number, it's 1. So all this is with respect to theta, don't forget that. We square the first one, it remains as 1. We multiply the 2. 1 times negative cos 2 theta is equal to negative cos 2 theta. Then we multiply that by 2, so it will be negative of 2 cos 2 theta. That's what we get. And then we square the last one. We are going to get cos squared 4 theta, because you're going to say negative cos 2 theta all squared. And when cos is squared, it becomes cos squared. When 2 theta is squared, it becomes 4 theta. Wow, yeah, that's it. So now what we're going to do is, again, okay, I see that I now have a cos squared, and I know that I still put the double angle formula. Cos 2x is equal to cos squared x minus 1. Oh, but 2 of them. So it's equal to 2 cos squared x minus 1. And that's what you must remember. But, what you must remember is that anytime you have that square, that trig identity being squared, then you must take it out. You must get it out. So it becomes 5 over 4 from 0 to pi over 2 of, okay, this was with respect to theta. If I find what my cos squared x or my cos squared theta is, I'll take 1 to the other side. I now say cos 2 theta or cos 2x plus 1 is equal to 2 cos squared theta. I divide both sides by 2, then I will get half of cos 2 theta plus 1 is equal to the 2 and 2 cancel, I get cos squared theta. So now I have, all right, 1 minus 2 cos 2 theta. And then for cos squared theta, I'm now putting, this was a plus, okay? So it's a plus, sorry. So it's now plus, because when you square a negative number, it becomes positive. So it becomes plus, cos squared is what? Cos squared theta is half, so it's plus half multiplying cos, because when it was cos theta, we got 2 theta here. But now it's cos of 4 theta. So it's cos squared 4 theta. So wherever there's theta, we are putting a 4 theta. So it's going to be half cos 2 times 4 theta. Okay, then plus 1. Right? And this is equal to cos squared 4 theta. Okay, so it becomes half of cos 8 theta plus 1 is equal to cos squared 4 theta. Oh, so really? So it becomes cos, we've seen that it becomes half of cos 8 theta plus 1. And all this is with respect to theta, all of it. They are integrated. So here we can put small boxes, then our parentheses are for the main thing. Now, of course, we like to split, right? So 5 over 4, we multiply everything. And the first is the integral from 0 to pi over 2 of 1 with respect to theta. Then minus the integral of 2 cos 2 theta with respect to theta from 0 to pi over 2. Then plus half is a constant, it can go outside. Then the integral of cos 8 theta plus 1, all with respect to theta. And this all is being multiplied by 5 over 4. So what do I now get? I get 5 over 4 multiplying the integral of 1 with respect to theta is theta, then minus the integral of 2 cos 2 theta. 2 can be outside, so we have that 2 being outside. Then the integral of cos 2 theta is sine 2 theta over 2. And we say now plus half is multiplying again cos, the integral of cos 8 theta is going to be sine 8 theta over 8. Then the integral of 1 with respect to theta is going to be theta. Okay? And as we can see, this is not power, okay? This is something that was for the previous stages there. So what we're going to have now, since we have arrived at this stage, we're going to have 5 over 4. We said it's from 0 to pi over 2. So we are going to have 5 over 4 multiplying this 2 and this 2 cancel. We have theta minus sine 2 theta. And then we can have half multiplying that. It becomes plus sine 8 theta over 16. Then plus theta over 2. Okay? All this is being multiplied by 5 over 4. And we want it from 0 to pi over 2. Okay. So now we can check. When theta is pi over 2, we'll be saying 5 over 4 multiplying pi over 2 minus sine 2 of pi over 2. Okay? Plus sine 8 of pi over 2 over 16 plus so this is it, the first one. Then minus, when we put 0, it's still 5 over 4 outside, okay? And then it's multiply now. Pi, instead of pi over 2, it's 0 minus. Sine, any sign of 0 is a 0. So it's sine 2 by 0 minus. We can just put zeros, okay, to save time. So this it goes to 0. And we now have theta over 2, which is 0 over 2, and that's 0. So yes, that's it. Okay, so it's 0 over 2, which is just 0. And we're going to get it being equal to 5 over 4 multiplying 2 by this 2 and this 2 cancel. We get sine of pi. And if you say sine pi in the calculator, you get a 0. So this, because it was a pi, is going to go to 0, okay? So now we have pi over 2, then plus sine 8 pi. So this 2 goes into 8, becomes 4. So we now have sine of 4 pi. And sine of 4 pi is 0 again. Okay, so it will be plus 0, then plus pi over 2. So now, so here we have pi over 2 plus pi over 2, and that's just pi. So it becomes 5 over 4 pi. And this would be your final solution for this question.